in this graph, or this one, we don't see jumps or holes. Alternatively, what if there's a point in an interval where a break or a hole occurs, as you see in this picture or this? To make this idea more precise, we need to understand when a function is continuous or not continuous over an interval, and that we will discuss in this video. Stay tuned. The intuitive definition of continuity is: the function is continuous over an interval if its graph can be traced without lifting the pencil from the paper. The function is continuous at x is equal to c, for example, if the following conditions are satisfied. Number 1, f of c is defined. Number 2, limit as x approaches c, f of x exists. Number 3, limit as x approaches c, f of x is equal to f of c. That means the limit is equal to the value of the function. Let's take an example. Determine whether the function given by f of x is equal to 4x plus 7 is continuous at x is equal to 5. As we mentioned earlier, we need to find f of 5 and limit x approaches 5 f of x, and check if f of 5 is equal to the limit or not. Let's start with f of 5. f of 5 is equal to 4 times 5 plus 7, which is 20 plus 7, which is 27. Now let's get the limit. As we learned in the previous videos, we use the direct substitution. Limit as x approaches 5, 4x plus 7 is equal to 4 times 5 plus 7, which is 20 plus 7 is equal to 27. Since the limit as x approaches 5, f of x is equal to f of 5, so the function is continuous at x is equal to 5. Another example. If the function continuous at x is equal to 2, where f of x is equal to 3x minus 5 when x is smaller than 2, and 2x plus 1 when x is greater than or equal to 2. We must determine whether the limit of the function as x approaches 2 is the same as the value of the function at x is equal to 2. We know that x is equal to 2 in the second part of the function. So to get f of 2, we need to substitute x with 2, and f of x is equal to 2x plus 1. Now, f of 2 is equal to 2 times 2 plus 1, which is 4 plus 1, which is 5. Now, so much for f of 2 as a value. Let's get the limit, but to get the limit, we'll look at left and right hand limits. So, limit as x approaches 2 from the left, f of x is equal to limit as x approaches 2 from the left, 3x minus 5. Now, the answer is 6 minus 5, which is 1. This is the limit from the left. And the limit from the right is limit as x approaches 2 from the right, f of x is equal to limit as x approaches 2 from the right, 2x plus 1. It's equal to 2 times 2 plus 1 is equal to 4 plus 1, which is 5. Since the limit from the left doesn't equal to the limit from the right, then the limit doesn't exist, and there's no need to compare between the limit and the value of the function as long as the limit basically doesn't exist. Thus, f is not continuous at x is equal to 2, it's continuous at all other x values. Alrighty, I hope you enjoyed this lesson. Don't forget to put your question in the comments below. See you next time.